All right. All right. Good morning, everyone. Week 5. You've got exciting, just one more week to go before your break. I hope you're having a nice, I hope you're ready for just a sleep. Wilson's number 1 hater, that's not nice. Morgan the stud, Jesus. All right, I feel like we've got like a Morgan appreciation fan club here as well. Oh, for the person online, the one asking about the forum questions, no, the questions about assignment 1 on the forum, they will start getting, Gab's answered it, don't worry about it, we're all good. Yeah, they will start getting answered. Sometimes there is a little bit of a backlog. All right, should we get the party started? Enough Wilsons have gone in. All right. Here we go. Let's see how everyone's feeling today. Oh well, good. 28 people still need to catch up on last week's lecture. Good job. All right, next one. Very weird way to ask this question. I shouldn't write questions late at night. Oh well, good job. Yep, so if I want command line arguments, then I tell my main they're coming as inputs. Okay. Oh, okay, yep, with spaces. Wilson Sang is finally on the board. Yep, A to I. Oh. Oof. Okay. Arg V0, Arg V1, Arg V2, Arg V3. Morgan, the start is really trying to win this whole thing. But is it the real Morgan? Very good. Very nice. Okay, we've got someone with a great answer streak. Last question. It's really going to separate out who's going to win. Oh, how can I? Oh, Gab, you're going to have to do some movement. Sorry. Oh. Is Morgan the stud in this room? Oh. Are you actually Morgan? Okay. Love that for you. What about GS? Is GS here? But are they the real initials? Yeah. Oh, okay, fine. All right. Truth telling. There's a third place. There's a third place in here as well. Oh, there we go. Amazing. All three people in the room. That's because online really doesn't have a chance because there's a delay. Someone can hear crying in the background. There's no crying. No one's crying in this room. Is anyone crying in this room? No, everyone's happy. Everyone's excited to be here. Okay, great. Can I get hands up if everyone's feeling good about week 5? What's the general vibe? Oh my God, 4 people are raising their hands. It's not that bad. I hope it's not 1511 that's causing issues. I hope it's maths. So there we have it. Okay, so don't worry. It's all about to pause for 1 week, which you will get to kind of replenish yourselves. So today we're going to do a quick recap of command line arguments because that was some of the lecture feedback that you would like to just quickly revisit it again. I'll do a lecture program for 2D arrays. I was really stressed that, all of you have kind of started the assignment. You might not need it, but there are people potentially online or even in this theatre that also need it. It's going to be similar to a bigger problem. And then we're going to do something called multi-file projects. So we're going to talk about that today. One of the feedbacks from the lecture last week was someone asking me to ask one of my tutors if I know what cooked means. So when I was your age, cooked meant something different, but I'm sure that it means that you're exhausted. Is that right? I hope it doesn't mean what it means when I was young, because then I wouldn't recommend doing that whilst you are not doing well and you need to be awake. I'm just going to go along with the meaning that you're exhausted. Okay, so last week we did all of that, which was very exciting. And then on Wednesday, we're going to do pointers, okay? So you've dreamt of it. I've talked about it a little bit. And it's going to be something, we're going to do it, and then you're going to just kind of let it sink in over week 6. You're going to forget all about them over week 6. And then you're going to do them again in week 7. I'm not going to be here in week 7 and week 8. Tammy's going to be doing the lectures. I'll be at a conference presenting some stuff. So I'll send photos and enjoy linked lists, which you will. I'm really sad, actually. I really love linked lists. Okay, live lecture code, usual location. I'm not going to do that because we'll just quickly do command line arguments again. I did prepare a program. Actually, hands up if you're in this lecture and also online. Gab, please, thank you. If you would like to do another program with command line arguments, hands up if you do. Okay, amazing. Good, so we will do that. So just to revisit command line arguments, basically command line arguments allow us to start running the program with some inputs already to start with. It's very useful if you're specifying, I don't know, a file that you want to start reading from straight away without using scanf and doing a whole bunch of things to start with. So that's what we use our command line arguments for. And they go into our main function, so we let our main function know that command line arguments are coming. Very exciting stuff. So instead of void, we change that to int argc, and for those of you that didn't know during the Kahoot, that is the count of the number of arguments that you've given on the command line, and char star argv. So for now, just pretend that char star is an array. It's more than that, but you will know what that star means on Wednesday, which is very exciting for you. Also, a real turning point for you in learning C. That's when you either start to hate it or to love it. So just wait for that. So when we run our program, we do our program name. That's always the very first argument. So that's always what's sitting inside the 0 index of the array. So that's argv0. And then everything else after that is incremented based on spaces. So you separate your argvs with spaces, and then they kind of move on up in the indexes of the array. Okay, so let's do a program. Here's one I prepared earlier. And it is called that's not where I wanted to go. Okay, common arguments, that's what it was called. I don't know why I chose this complex program to do, but there we have it. Okay, this program prints out the most, oh God, I'm regretting this choice now. Anyway, we're going to do it. This program prints out the most common argument, excluding the name of the program. So if there are multiple equally common arguments, print out the first one in the list. What that means is if I run a program with the name of the program and then I give it on that line cat, cat, cat. My God, even my example is awful. I'm sorry. Dog, 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 dog. The output would be cat because case sensitive, so it's kind of considering this to be different to this. I hate myself, so feel free to hate me for this as well now. This is really awful. What are we going to do? And then okay. So how are we going to solve it? What do you reckon? What will be our vibes? What are some potential... So always just think about how am I going to solve it before I start coding. No one knows. No one cares. There was a hand. Yes, go on.
For loop to loop through each index of the array of argv.
Okay, yeah. Okay, I'm going to loop through my argvs to see where, to see what the term is. So let's talk about some steps. Loop through your argvs to see what is in there. What will I kind of check it with? Who will I loop through? So let's say I've got, if we're to separate, let me give a better example, a shorter one, and then we can talk about how to solve it. So let's say, for example, I'm going to run the program with program, and then I'm going to give it cat, cat, dog. Okay? That means that in this program, I've got argv0 that I don't really care about is that program. argv1 is going to be cat. argv2 is going to be dog. And argv3 is going to be, that was incorrect, cat. And then this one is dog. Okay. So, yeah.
You might want a struct which keeps the string and how many times it's
I could want a struct, or I could have an array, or I could have any number of things. Yeah, sounds good. Why would you choose a struct in this particular case? What do you reckon?
Well, I'm thinking there's a string and
Yep, so you are saying you want it to be a struct so that you can hold on to the thing, the actual name of whatever it is, plus the number of times it's occurred. Okay, so we can do that, absolutely. So let's, okay, maybe a struct to hold on to whatever is happening, and then we might have an array of structs to hold on to many things. It's not the only way to do it. You don't have to use a struct. You can have an array and just kind of count things out based on the indexes that they appear as well. What are some other steps? What do we think? What function would I use to compare things? Yeah. String compare. Okay, so when I want to compare two strings, I'll use strcmp. And if it is equal to 0, then the strings are the same. Okay, great. All right, should we start writing some stuff? It's really throwing me off because Aditha is commenting on there, but he's not there. Okay, so let's start writing. What should we have in here? I love it. I've left it completely empty. Yeah.
You want to start off with a for loop going up to Args.
Okay, let's start with a loop. Okay, why not? That's a great place to start. Loop through the argv's, because then we can see what we need to do. It's a great place to start. So for int I is equal to 0, I is going to be less than argc, because that's the number of arguments that we have, and then we're going to increase it. Okay, now if we start at I is equal to 0, that means we have our program name, because that's the 0th thing in the array. Do we need to consider our program name? Not really, so we could start our movement at 1 if we wanted to, in this case. It depends what we're doing in that loop. You could start it any way you want. Okay, and what are we going to do inside this loop? What do you guys reckon? What are we going to do inside this lovely loop? We've gone into the loop, we're going through, we want to compare something. Go on then. Yeah. Okay, compare the string to what? To which, so let's say I'm right now, in this moment, when I've just entered the loop, I'm at argv1, okay, which is cat. What do I want to compare it to? The next one over, yep, so argv2. So I want to, if string compare between argv I and argv I plus 1 is equal to 0. So if they're equal, then what do I want to do here? I want to increase something, yeah? But I have nothing to increase because I'm not really keeping track of them. So how about we do, should we have a struct to keep track of what's going on? How do we feel about that? Struct, or does anyone... Someone's like, yeah, let's do a struct. Others are like, what's a struct? Things are going really well. Okay, let's have a struct here that we're going to keep track of. So struct, pardon? Okay, sounds good. I'm going to just make it short just for this case, okay. And I'm going to define it to have a char name, and the name, I'm going to have to give it a size. Let's just go 20, why not? And we're going to have int count in here. Okay, so I've got this struct that will keep track of what's going on. And before I commence it, I'm going to say that I actually want an array of these structs. So unique, and I'm going to call it unique arguments. And it's going to be an array. And how do I know this is going to be ugly? Because I have to make a decision about how many, what's the size of that array before I go on. Okay, so great. We'll just, 20 is an arbitrarily chosen number by me right now. Okay, what do I want to do? How do I initialize it? It's going to get ugly now. Ish. Yeah.
Can we make this instead of 20 put Args?
I could do that. Yep. And that will, but you could do that. Yep. Yeah.
We should also have a default condition within the for loop saying that if we're checking the very first argument, I don't, wait. The question is basically we're finding the argument that appears
The most times. Yeah.
Shouldn't we be comparing by taking, when we reach the first argument, because it's the first one, we create a struct for
Okay.
and place it count to 1. Then once we move on to the second argument,
Yeah.
we take that second argument and compare to every single element within the unique argument
Yep.
and see if the struct name is the same as the argument.
Yep. So sounds like we might need a loop inside a loop. Yeah? We could. It could be. Or we could, if you want to do it with one loop, we could. We could just increase the loop by doing I plus 1. Who's lost? Who's found? A few people are lost. Thank you for being honest. It was a cooked question to choose. This question was an old exam question, which is why I chose to use it. A very old exam question. Okay. Okay. So what we're trying to do is we're trying to pulse through and count up the number of arguments, how many times it's occurred. Okay. So let's just for a second, okay, let's remove the struct, okay, because sometimes the struct confuses people. We can do it with a struct, and it is actually a really neat way to solve it, to use a struct, because you can keep track of what's going on. I'm going to have just a simple array of ints that will count for me, okay? And I'm just going to initialize it all, and I'm going to initialize it all to 0, okay? So that's just going to be my array where I'm going to hold things in. 20 for, I don't know, why not, okay? Okay, so now I've got my first loop, and what I'm going to do is I'm going to compare the two things, okay? And what I'm going to do if the two things are the same, so that means here I'm comparing if it's 1, I'm comparing 1 and 2, so I'm comparing whatever was in 1 and 2, which is cat and cat. So it's going to be equal to 0 because they are exactly the same, which means I'm going to enter into this if statement. And now I want to increase something. Okay, so I think one way to think about it is I can fill up the array based on where the argv occurs, like in the same position, if that makes sense. So I could be filling up my array. So let's say that's not what it's called unique. We'll run through this code, don't worry, I will find you. Okay, so I'm going to place into unique, and I'm going to place into the very first component. Maybe let's just put it into I. I'm going to increase whatever's in there. Okay, right now there's a 0 in there, so what I'm doing is I'm making it 0 plus 1. Okay, amazing. Let's just have a look what this does, just so that you can see what it's actually doing in this for loop. So we're going to see what is actually inside each one of the, each thing in the array, just for your sake, okay? And I++. So all I'm doing here, this for loop, is a debug, okay? So debug for me to see what is inside my array. Okay, and all I'm going to do here is I'm going to print out whatever is sitting inside my new array. Just so that you can check how it is counting, which is something that you should be doing when you are working through things. Okay. All right, so let's save it, and let's, oh, I'm in the wrong. Okay. Oh, okay, so now let's run it and let's give it those cat, dog. Okay. So something has happened, something's not working. And why isn't it working? What do we think? Yeah, so I'm indexing something that's outside the array because I'm going to the count of argc. So if there's, what I've entered here is I've entered cat, dog. There's 1, 2, 3, 4. So there's 4 arguments, but my 0, 1, 2, 3, so I'm going outside of the array bounds. So to fix that, I'm going to subtract 1 so that I have in the wrong one. Okay, let's try that. No. Compile first and run it. Okay, so we've got cat occurs 0 times, cat occurs once and dog occurs 0 times. Okay, so kind of cooked counting, but that's just a problem with counting. Okay, so what would we need to fix here? What do we reckon? Yeah. No? Okay. Fine. Okay, it's just the counting that's, yeah. I could do that, but then I could just modify my counts as well, just to make it, yeah. Okay, just over here, I've got to subtract 1. Okay, so over here I'm subtracting 1 because I've got, when I run it, okay, my argc is equal to 4 in this case. So I've got common arguments as my first argument, cat, and dog, okay? But I can't access to at index 4 because there's no such thing. So, because this is 0, 1, 2, 3, so I've gone out of array bounds, basically. It's like a one-off error. I can't go to the last one. I've got to stop before it. Okay, this is taking too long because I chose a crappy question. My fault. I hate myself. Okay. I'm really tempted to leave it for a second and move on. Who wants to keep going and who? Okay, hands up if you want to keep going. Just 2 people, 3 people, 4 people, 5 people. They just want to watch me sweat out here on this terrible question. Hands up who wants to move on. Okay, I think we're... Keep going, please. Okay. I sure can. What a nice idea. And then you can see what's going on. Fine. Okay. Oh, keep going. Okay. I can just solve it, but then I feel like no one's learning anything as well. Okay, here we go. Let me minimize this. Let me do that. Okay, and let's see what's going on here now. Okay. Now let me find where that is. Here I am. Okay, so let's see what's happening. Okay, we've got our int main argc char argv, which means when I run my program, the very first thing that comes in, if I'm running it like this, and we'll just pretend it's program, and I'm giving it cat, dog, what's happening straight away is I've got argv at 0 is equal to program. Argv at 1 is going to be equal to cat. argv at 2 is going to be equal to cat as well. And argv at 3 is going to be equal to dog. Okay, so that's what we have to play with. Now we go in here into our int whatever. We've got another array that we've declared, and this array is called unique. So I've got an array unique, and there's 20 elements to this array, and they're all kind of starting at 0. Okay, 20 is arbitrary for now. Okay, then I go into my first for loop, and when I go into my first for loop, I create an I make it equal to 1, and then the I is going to keep going until argc is minus 1. So in this program over here, my argc is going to be equal to 4 because I've got 1, 2, 3, and 4 arguments going into this program. So argc is equal to 4, which means that over here I'm testing until 4 minus 1. So the condition is that I has to be less than 3. And then we do I++, and it starts at 1. Okay, then we go in here and we do our condition. So if string compare argvi, so my I is equal to 1, which means that currently I am comparing argv1 and I+1, argv2. So I'm comparing these two things over here. And they are exactly the same, which means that this condition is going to be equal to 0. It's going to be true. So then I will go in here and I will add 1 at index I. So that means unique at index 1 is going to be equal to 0 plus 1. Yeah? Okay, great. So that's going to be equal to 1. Oh, that's... Okay, great. I'll come out here and I'll go back and I'll check what's going on. Okay, so my I will increase by 1. So it's now going to become 2. I'll check the condition. So is 2 less than 3? Yes, it is. So I'm going to go back in and I'm going to check again. So if string compare, my I is now equal to 2, which means I'm comparing 2 and 3. So now I'm comparing these two, 2 and 3. Are they the same? No, they're not. So I'm going to skip that, which means that unique at position 2 has stayed the same because I initialized it over here. It still stayed at 0. Okay, so I'll increase the I by 1. Great, and then I'll check my condition again. So is 3 less than 3? No, it's not. So I'm going to break out of it, which means that I, never keep going past. Okay, and then I'll go into here and I'll start checking. So my int I is going to be equal to 0 again. So this is my next function now. So int I is equal to 0. The condition is that I has to be less than argc, which is 4 minus 1, so 3. And I'll print out whatever is sitting inside the array. So at unique 0, I've got a 0. So it's going to print out a 0 because it was initialized. I haven't changed anything. At unique 1, I've got this 1 over here. So I'll print out a 1 because that was what was sitting in there. And at unique, the next one, so at unique 2, I've got a 0, so I'll print out that. Okay, so that's how that code is working, but it's not quite right, is it? It's not quite picking up what's going on. But it's counting things, which is always nice. All right, what do we think? What should we change? What should we do? Yeah.
I would like to suggest that we should start all over by starting at agreeing with a method to solve the problem first. So then we can
yeah.
plan for the same.
Sure, we can do that. Who wants to do more of a method to solve it before coding again? 1 person, 2 people, 3 people, hands up. Yes! Come on, a bit of life. My God, this is not going as well as I thought it would be. Okay, what do you think we can do to solve this problem? Okay, what do you think our method will be? Okay, let's do it over here so we can see the code as well. Okay, I'm going to take what am I going to take? I'm going to take the first argument and compare it to the second one, which is what we've been doing. I'm going to learn how to spell. Compare to the second argument. If they're the same, I'm going to add to something. You're going to have such a great time during the exam. Yeah. Absolutely could. I could do that. Yeah, I could just start, doing my counting from ones. I could just initialize the whole thing to ones. Go wild. Yeah, I absolutely could do that. Or I could just, who cares? If it's 0, it's 0. It's still going to be kind of the same. The maximum is still going to be, I don't care about the count. Yeah, I just want the one that occurred the most.
One of the methods I believe we can use to solve this problem is going through the loop for every single argument. But the moment we reach each argument, we compare it with every succeeding argument.
Okay, so often when we have these types of questions, and I'm going to draw it here, what we want to be doing, okay, and what sometimes is easier to do. Let's say we have this array of arguments, okay? This is my program name. This is my cat. This is my cat. This is my dog. What we want to do is we want to focus on one thing. We want to stay there, and then we want to compare it to this one and compare it to this one, okay, and record it from that. And then we're going to move by, and then we're going to do that again. So we're only comparing it to the ones that have come afterwards as opposed to the ones that have come beforehand. Oh, I can see people just like losing the plot. Don't cry. Please don't cry. Please don't cry. What do we think? Should we try that? Yeah.
One more suggestion.
I should just get you up here. You go on. Oh, all right. Go on. Love that. Look at this. Yes! Ah, the bravery. Thank you. Of course you may. Go on. Show us what you would do.
So, like I said before, my method would be taking the first argument, compared with every other. Compared with other succeeding argument. If you find it the same, I need to say, we need to have the first array of struct to keep our result. Actually, can I draw?
You sure can.
It's going down, right? Okay, perfect. So the first step is to create a struct that contains all the unique arguments within the whole argument thing. Then the second step is to loop every single argument one by one and comparing it to every other succeeding argument. When we found that the two comparing arguments are the same, you go back to the struct array and then find the struct which has the same name of the argument, increase its count by 1. Then after that, since we're comparing, like for example, this is our cat and cat, right? You then change the value of this second cat into a spacebar. The reason why I said spacebar is because I don't believe there's any time when an argument value could become a spacebar. And the reason why I'm doing this spacebar is that after we compare the very first argument to every other succeeding argument, we moved on to the next argument as our base. And since this base is a spacebar, we just ignore that fact. Now, when we found another new... Oh, sorry.
Just check how everyone's feeling. That was...
Yes?
Oh, good. One person's... Yeah.
Okay.
They're cooking slowly,
and
simmering.
Then when we found a new unique argument, we then go on to the next struct, which is creating a new struct of that new argument. We repeat this until all the arguments have been read. Then we go back to the struct array and find the one with the highest count.
Okay. I like what you're doing. I do. That would solve it, okay? All I was trying to say is I don't really need to keep track of what the terms are because I can keep track of the index and it will give me what the term is in argv.
That is true.
So I don't need to, it was just
It was just referring back.
Yeah, I would just refer using the same index to an argument. But let's please, a round of applause. How brave was that? That was so brave. Well done. And a good explanation. Okay. Good job. Okay. Let's just, you know what, let's just, we've got something that counts things. Amazing. We've got something, we can see what the numbers are. The numbers are slightly off. But let's just kind of go through now and just see if we can print out the one that's got the most, okay? And that might give us exactly what we need. Who knows? Okay? I'm going to do just a simple thing to finish this off, and then I will tidy up the code and make it available to you as well, because I feel like everyone is cooking and simmering, and we really need to move on because you're fried from this. Okay, I'm going to keep track of the index where the most things has occurred as well, and then what I'm going to do is I'm going to have another loop, and in that loop I'm going to just move through again, and what I will do is I'm going to check what is sitting inside this unique array. And if what is sitting inside unique array is greater than my maximum, so I'm really just finding the maximum number in that array that I've kept track of. I'm going to change it. And then I'm going to also keep track of the index where this has happened. And the reason it's I+1 is because in my argv, I don't care about 0. I want it to be the one, okay, the one that follows. We can do it, we can run through it. Don't worry, okay? And let me print out my final statement. I tried to do it in a really simple way, and I don't think it was a simple way. I think it was convoluted. So, yay. Okay, and let's print out whatever on earth happened here. Okay, let's see it going. Let's see it running. Okay, let's run it. It compiled already, a minor miracle, and it's printed out the right thing. What happens if we, I don't know, do the dogs now? It did not really appreciate that. So the code is not quite working. Something is wrong, and something is not working, and it's been 48 minutes. So I feel like I will tidy up this code. How about I record a little video and walk you through it? That's not asking you for suggestions as well, which probably created quite a situation where we were running late. How does everyone feel about that? All right, let's get back on track, because this is, if I start debugging now, we might be here for a long time. Okay, this is one of the later questions in the exam. Don't worry, the first questions are much, much easier. Well, are they? Okay, let's quickly have a look at this, which was meant to be the main event today, and it was not. Okay, so before I realized what cooked may or may not mean, I went on a bit of a hunt. Week 5 of your first programming course at uni, you're fried. CSC's organised a big cookathon to get everyone back to feeling great. I don't know why you would cook to feel great, but there we go. You enter the big CSC kitchen on level 1. It's not that big and it's not that nice. And join the fun to do some cooking. You start out at the refrigerator to get some food to prep. But you're so tired from all those sleepless nights doing your assignment that you keep starting fires everywhere. So you are a bit of a hazard. You realise that there's a burning smell in the fryer, but where is the fryer? You need to move around the kitchen to find the source of this fire. So much going on. Okay, kind of similar to your assignment 1, not at all really in the context, but kind of similar in that there is a kitchen. We're going to pretend that it's a square kitchen, and you need to move around that kitchen. You're going to need to move around that square. So you'll need some initial input to get a map of the kitchen. You'll need to know where the fridge is located. You need to know where the stove is for later maybe. You need the location of the fryer because that might be where something is, burning. You might update the map with these details and then you'll keep getting user input and we'll use the WASD keys to go up, down, left and right. And you'll keep going until you find a fire. So we're just moving through a 2D array basically. Okay, so you will do it until Control D is pressed, and then when you get to a stove, you realize you can start multiple fires. So really, this has become a pyromania question. Okay, you get some starter code, just like in your assignment 1, and your starter code has 3 functions in it, similar to your assignment. One of those is an initialize map function, and that is the function that initializes the map with the initial values. Then another function to print the map, and then another function to print the location. So again, similar to what is happening in your assignment. Okay, so your enums in this problem are, you've got an entity, chef, food, fire, face up, face down, face left, face right, and empty. And you've got a place type, stove, fryer, oven, refrigerator, clean, because who doesn't like a clean kitchen? Okay, then you have a struct location, which is made up of the entity and the place type. So it's made up of the 2 enums, and it's holding on to an entity and a place in it. What does that mean for us? Okay, it means that you have this struct location map, and the map is 8 by 8. So it kind of looks like a 2D grid, something like this. And when it's initialized, let's say in the first instance, then something in this square and in every other square is going to be the same, but it's going to have a dot entity and a dot place everywhere. So each one of the array indexes is going to be a struct, which means that it's storing both an entity and a place in it. Okay, so what we have is this struct location map, which is a 2D array, and because it's of type struct location, the 2D map array is made up of the struct locations, which is the entities and the places, and then entity is one of these ones and a place is one of those ones. So you will initialize it by having every entity as empty and every place as clean. Okay, so what it looks like once it's initialized. So you will ask, where is the refrigerator? You'll give some sort of input. So at 1, 2, and that means a fridge will be placed at 1, 2. And that's where the chef will start as well. You will then ask where is the fryer, and the fryer will be placed at 2, 3, and that means that something at the point 2, 3, at row 2, column 3, is going to have a fryer, F for fryer, and an exclamation mark for a fire. And that means the place is going to be fryer and an entity is going to be fire. And then you might get asked where is the stove, and the stove will be placed at 4, 5, and the place will be stove, so S for stove. And food, I think it was a question mark. Not sure why. Okay, and any other square that is initialized but we haven't placed anything on it, it's just going to have an entity as empty and the place as clean. And then the print place function is the one that prints it out to look like this, right? So you don't have to worry about it. Okay, so let's have a look at this starter code. Okay, so in our starter code, we start out with our 8 by 8 array. We start out with the 2 enums. Just close this. And then we've got our struct location. Okay, we've got our initialize map, we've got our print map and print location. So that's what's doing all the stuff for us we don't need to worry about. So this is the one that sets everything to clean and empty, which means that my 2D array is initialized and I can work with it. This is the one that prints out the map. And this is the one that kind of accesses the enums and sees if there is, a fryer, print out an F, if there is a refrigerator, print out an R, and so on and so forth. And then it does the same thing for entities as well. So it's printing them out. Okay, so when we go into our main, the first thing that we do is we initialize our map, which means that we now have an array that actually has some values in it and that we can do something with. And then we need to do some stuff, okay? So the first thing that we needed to do was we needed to get some input from the user. Okay, so let's get the input of where things are located. So I'll do the fridge first, so fridge row, and I'm also going to have another variable, fridge column. I will then ask the user, I really shouldn't have deleted that from what's going on. Where is the refrigerator? And then I'm going to scan in 2 values to take up what's going on. So I'm going to scan in a 2% Ds, which will give me where it's located. And I'm going to put it into fridge row and fridge column. Okay, great. And then I really need to do the same thing for the fryer and the stove because... Okay, so I'm going to change these two. This is going to be the fryer. Thank you. And this one's going to be the stove. I didn't really want a stove to start with. Anyway, okay, stove is there. Okay, so now I'm taking in 3 different things, and that means that I need to update my map to account for them. Okay, so I've scanned them in, so now I need to do something. I should probably check that the inputs are valid, yeah? I need to know if they are actually sitting on the map, because what if someone enters 88 and I can't do anything for it, okay? So I'm going to do some checking now whether all of these things are going to be valid or not. Okay, so let's check for valid inputs. Okay, how do you reckon we will check for valid inputs? What do you reckon we will do? What's a valid input? Yeah.
Since you're checking multiple times, is it a good idea to make a function that checks if the input's valid?
Absolutely. That sounds like a great plan. I would absolutely make a function, as I would in your assignment as well. I would absolutely make a function to check for validity. So let's make a function to check for valid input, because we're going to be using it over and over again. Okay, and I'm going to check it here. So this function will check for valid input. And what's going to be the input into the function? Row and column, yep. So 2 ints. And what's going to be the output, do you reckon? How will I know if it's valid or not? 1 or 0. That's a great thing. So I'll return an int, and it's going to be 1 or 0, depending whether it's valid or not. Valid or not valid. Okay, so int and check validity, and I'm going to give it int row and int column. Okay, excellent, good. Okay, so then what do you think I'll be checking in here? How will I do the checks? What do we reckon? Okay, just a simple check, right? So we can just say, okay, what will be my condition? Yeah, if greater than or equal to 0 and row is less than and equal to map rows. Can it be equals to there actually? Yeah, no. So it depends which way I check, but I really don't want it to be equal. It can be 0, but it can't really be equal to map rows, because that means I'm out of boundaries. Okay, and then I'll do the same for my columns. So and column has to be greater than or equal to 0. And column has to be less than column map cols. Okay, great. So if I fit into all of this, then I'm going to return 1, because that means that things are going well for me. Else, return 0. Yeah, Okay, so I've got this check validity function now. What should I do with it now? I'll use it, right? Should we use it? So it's going to return 1 if it's a valid input, and it will return 0 if it's not a valid input. So let's use it over here and let's check for it. So I want to check that my inputs are valid. So if check validity, I'm calling the function, and I'm going to give it the first 2 rows, so the fridge row and the fridge column. So I'm going to give it fridge row, fridge column to go with. Okay, so if that's valid, so how am I going to check if it's valid? Or I can check that it's not valid. So if that's not equal to 1, then I'm going to say that it's not valid. Okay, but I have quite a few things to check. Can I include them in here as well? How can I check for all of them? Yeah. Well, how can I check? So I've got fridge rows. How can I check the stove rows and the fryer rows as well in the same statement, so I don't have to do it 3 times? Yeah, I could just check using an OR statement. And then I'll also check the validity of this one. So check validity of fryer row, fryer column. And I'll check that's also not equal to 1. And I'll do the same for the stove. That's too many things here. Yeah, yep. Thank you, and one in here as well. Whoa, that was a celebration of brackets. Okay, so what's this going to do? This is going to check the validity, and if it's not equal to 1, or if this one's not equal to 1, or if this one's not equal to 1, I'm just going to say input not valid, and then call it a day. Okay, all right, great. Then I'm going to print the map. Shall we see what it prints out? Okay. Okay, so the first thing it's going to ask where's the fridge. The second thing it's going to ask where's the fryer, and then where's the stove, and it's going to print out the map. So that's it's gone through the whole thing and it's placed them. Did it place them in the right place? 1, 2. So 0, 1, 0, 1, 2. So that's placed the refrigerator in the right place. I assume the fryer and all the rest of it is placed in the right place as well. Okay. Now I didn't give it, the wrong inputs, so I kind of didn't really. I'm going to Control D to exit out of it. Okay, I haven't checked if my inputs are working. So that's something to check. If it's working, my check validity is working. I do want to do that. Okay, so what should we do now? Let's find this fire. We want to be able to move around this board and find where on earth this fire is located. Does that sound good? So I want to be moving across this 2D array, and what I want to be doing is I want to be visiting each spot until I get to a fire, and then I want to finish up. I'm done there. Okay, so I'll keep the print map, and then I want to be able to scan until I get scan something in, and then I want to keep moving. Okay, so how will I do that? What do we think? What do we reckon? I think maybe another function to find the fire. Hard audience today, hard audience. How is everyone? Can you do an online poll? I feel like maybe, how is everyone feeling right now? I had a thumbs down, I had a thumbs up. a thumbs up, a thumbs up, a thumbs up, kind of comme ci, comme ça. Is anyone getting value out of this program right now? Yes, a few people over there are. Okay. What about online? Can we get a 5-minute break? Yes, you can. All right, let's have a 5-minute break. Okay. Sure. Yep. Yeah. Talk to me.
I'm struggling with the first question for that.
Which one?
The string compare. I'm making a function for string comparison. It doesn't work. If you use the slash for character, it doesn't work. So basically, when I run it, just for example, if I compare the string I can A and C, that's
You got an enter sitting in your bumper, I think.
I mean, why doesn't have
Oh, well, first of all, that's very naughty over here. Using scanf with a string. Please don't.
But I mean, by default, it says
You shouldn't use scanf with a string. You can use fgets to get a string in from the line.
oh, I mean,
There is a reason for that. You can cause some serious buffer overflows with that.
we need to use the fget function.
You need to use the fgets function to get the string. Yeah. Don't use the scanf to get a string.
Syntax for fget.
Pardon?
There's a syntax.
In brackets, you've got the array that you're reading into, and you've got the size of the array, and then STZIN. So you're reading from standard input.
But at the beginning, I was thinking just to like array, compare with one by one.
Yeah, so to do the string, you just compare the characters until you reach the null terminator.
Like /0.
So use fgets, don't use scanf. Very unsafe programming practice to use scanf for scanning a string.
So I mean, I download from that website. Just by default, scan. We need to change it.
It's given, yeah.
Just give it
Don't use scanf. Yeah. It basically wants you to stop. Yeah. Well, it's not going to be a short question.
It is actually a short
Okay.
question. It's not a help question, it's clarification. Does that so obviously each file has a maximum number of users.
Yeah.
Does that get used when it's maximum? And or does that mechanic last?
It's a very good question. I need to read the assumption. Yeah, thank you.
I want to ask about this case so I make the code, see it, I run it manually, it works, but when I put it into the other test, when it control these, it gives up like 10,000. Yeah. like I cancel it out.
You have to, the condition has to be something that is equal to. So when will you stop? As in like, I is equal to what? When should you stop reading the control? Okay, so to do the control Z, right, over here you would check that the scanf, what scanf is reading in the terms is always equal to 2. So you would read it, that's your condition. So you stop, so control, when you press control, okay, what it means is scanf doesn't scan it at the end, what happens is like -1 usually goes.
So basically, like,
So when you're doing a while loop, you press return, 2 things. You're scanning here, that means you want to. This statement here is equal to 2. That means everything's okay. But if control is pressed, it's not going to be equal to 2, which means you exit out of this.
so basically, I need it if so that if the form is true.
Well, you need to remember this is the condition is going to be whilst you're scanning that here, there is equal to 2. Because 2 is the reading. So your return to business is
Okay. Alright.
just try it out. Try it. Equal to 2. Double it, because you're not assigned. Check the case. So then you want that instruction to maybe go outside.
Wait, but like,
You might need to take that inside, right? You might need to change the position. But just try what it does. Your positions are going to be wrong. That's okay. Just run it now. Okay, it's waiting for the input. It looks like there's also printing statements.
yes, it's just taking
See what I mean? Just use the plain void statements. It doesn't match up right now. You need to push instructions. Does that make sense? Okay. All right, let's get back to it. That was okay. Excellent. Okay, so someone online asked, yeah, let's get cooking. Someone online asked, can we just quickly go through what on earth is going on here? And we sure can. I would not deny you that amazing privilege. Let's quickly go off and see what it's drawing for us and why it's doing it. Okay, so I have a function. I have many functions. Okay, so let's see where it's actually doing stuff for us and see how it's and what we need to change. Okay, so over here we've got our struct location map, which means that what's happening is we are creating this beautiful map that's got 1, 2, 3, 4, 5, 6, 7, 8. Let's pretend that's working for us. Okay, so when we go into our main on line 40, we create a struct location map rows and map columns. What that means is this map is created, and this map is made up of all the rows and columns, so 8 and 8. So 0, 1, 2, 3, 4, 5, 6, 7. Okay, and that means that each index inside this map has a struct location in it, which has an entity and a place. I then call the function initialize and give it this map to go with it. Okay, so if we go down and we go to look at what that function is doing, just so that we can see what's actually going on, we go into this function and we've got a variable row is equal to 0, which means that we're starting at our 0th row over here. That's row is equal to 0. Whilst row is less than map rows, great, that still counts because 0 is less than 8. I'm going to go in here and say column is equal to 0, which means that I'm now sitting over here. Okay, whilst column is less than map columns, yes it is, because 0 is less than less than 8. I'm going to say this is true. I'm going to go into this while loop and I'm going to say map at row column. So I'm sitting at 0, 0. I'm entering the place member of the struct and I'm saying it's clean, okay? Which means that the clean is going to make a space and then the entity is going to be empty, which is a dot. So if I go down to the way it's printing over here, sorry, the opposite way around. So clean is a dot and empty is a space, okay? So I've got a space for empty and a dot for clean. Okay, great. So that's initialized it to that. I'm going to increase my column, which means I move over one more and I do the same thing. And then I go again and I go again and I go again. So what ends up happening is that I have a whole array that's basically got space and a dot. Okay, I'm using a dash for space just so that you can see it. But it's going to look something like this across the whole array. There's a little lag on how it's updating the actual drawing. Okay, so each one of these is going to have a dot and a space in it, okay? And then it's going to keep going, and that's going to initialize the map. After I initialize the map, what I'm doing is I'm asking the user, where is the fridge? And they're entering 1, 2, right? That's what I entered before, which means at row 0 and row 1, I'm going to need to do something. So at row 1 and at column 2, over here is going to be a fridge. That's where I said I want a fridge to go. Then here I think I said 3, 4. So then at 3 and 4, I'm going to put something. And I don't know, let's put something over here. Why not? We can just decide where it goes. So let's say those are going to be our... Okay, over here we're checking that they were valid inputs. And we will run through that function as well if you want. But what we're going to do is we're going to actually put those things on the map. Okay, so let's actually, I don't know how it was printing out before nicely like that. Let's put it on the map. So right now my map is sitting just as initialized. Everything is a space and a dot. How will I say where the fridge has gone? I'm going to really have a fight with this keyboard drawer one day. Okay, so I'm going to update what's happening at the fridge row and a fridge column. Oh, I know why. Because I was compiling a program that I had written before that is actually full. That's why it was working so well. Okay, if I compile this one, it's not actually going to print out this beautiful map. I was compiling the one that's actually fully functioning. I was wondering how that was happening. Wow, I'm a genius. I'm now doing code just by thinking about code. If I so let's if I compile this one, also there's errors, so great, because I forgot to prototype it. So let's quickly prototype it. So I'll just move that out. And comma. Okay, great. So now let's actually run it. Okay, now I've got the wrong name. Isn't it fun coding with me? Because it's full columns. Okay, let's try it now one more time. Third time lucky, yep. And if I run it now, what it's going to do is it's going to take these inputs and it's going to do nothing with them, right? Because I haven't actually placed anything. So it's created that array, as I was saying, everything is just a space and a dot, a space and a dot, a space and a dot. I've taken the input in, but I haven't changed anything in my array to say that that's where something else has gone, okay? So the print function knows what to print is because I check what is inside the array element, and then I print it based on that. So when I initialize it, I basically set every place to clean and every entity to empty. And when it goes to my print, what it does is it checks, okay, if it's clean, then you print out a dot. And if it's empty, you print out a space. So that's how it knows what to print. And you guys get given the function that will print as well. So makes it a bit easier, not as intense. So now what we want to do, now that we've got these inputs, we know where the fridge is, we know where the stove is, we know where the fryer is, we want to actually put them on the map. Okay, so what I'm going to do is I'm going to access my 2D array, add fridge row, fridge column, and my array, two-dimensional array, is an array of structs, which means that I've got two things that I can access. It's either going to be an entity or a place, okay? Now, if I've got the refrigerator, it's a place, so that means that my dot place is going to be equal to refrigerator. And what I said in the other, in the part where I described the spec is that that's where the chef will start as well. So that means my fridge row and fridge column accessing the entity part of the struct is going to be a chef, which is defined in the enums, okay? So in the enums, I can have a stove, fryer, refrigerator, and here I can have a chef or some food, okay? All right, so that means that what's going on is I've now kind of set the array of where the person wanted to place their fridge. I've actually passed that along, and I've said where those things are going to be. So at fridge row and fridge column, which is what I scanned in, then you're going to have a refrigerator, and at fridge column entity, I'm going to have a chef. Okay, great, and I'm going to do the same for my stove and my fryer where I scan them in. So I'm going to do the same at the fryer rows. So my fryer row and my fryer column. That means that the place is going to be where the fryer is, and at my fryer row and my fryer column, that's where the entity is a fire, because at the fryer there is a fire. Obviously. Thanks, Gab. Okay, and then the final thing is a stove, just to keep it going so that you can see that I'm just manipulating the array. I'm just changing where things are going. Okay, so then my stove row and stove column. So my place is going to be a stove. And apparently there's going to be some food as the entity. Okay, all that's doing is that it's now giving, yeah.
What if the user inputs the places in the same tile?
Okay, that is something that you should absolutely be checking for, yeah. So that is something that we would start checking for, because we don't want to have a fridge placed in the same place as a fryer. That would be, it could probably save us from the fire. But yeah, that is definitely something we need to check for inputs. Yeah.
When you check for the valid inputs, you just move on. Shouldn't you do something like stop the function or something?
Absolutely, I could just exit out of this because the valids are invalid. I could exit out of it by returning 1, or I could ask them to do something again, yeah, depending what the spec is telling us to do. Very good point, okay? All right, great. So, so now that we've set this, let's print the map, okay? Maybe let's print the map here as well, just so that we can see how it changes once we've reset once we've reset things. Okay. Okay, so let's see what that does, okay, now that we've set what the things are going to be. Okay, let's compile it again and let's run it. And okay, so now what it's doing is the first time I print, oh God, I should have printed a new line. So the first time the map is empty, and then that was the first time I called print map. And then the second time I called print map, I actually placed the fridge, the fryer and the stove on it, okay? And all of that happened because I basically manipulated, I told what now goes on the map. So I manipulated that element of my two-dimensional array to say, actually, there's something in there now. Okay, so what I want to do now is I want to be able to move around the map, okay, to find this fire. And to move around the map, what I'm going to do is, what would I need to do if I wanted to do a function to find the fire? Where's the fire's at the fryer, I'm at the fridge. So that means that I would need to pass the coordinates of where I'm standing and where the fire is to my function. So let's do a find fire function. And let's give it where I'm standing. I don't really need to do that. I'm just actually now defining the function. Apologies. Okay, so I'm going to give it the fridge row and column, which is where I'm standing. And then I want to give it also where I'm moving to. So I'm going to give it fryer row and fryer column. Okay, so let's do it as a function now. Oh no, I fried you. Just wait till the multi-files come. Okay, so let's make it a void function, and let's do find fire, and we're going to give it 4 ints, which is where we're standing and which is where we're going. So I want to be moving around the map, and I want to know where I've moved on the map, just so that you can visualize it as well, okay? So what I'm going to do is I'm going to say, okay, I'm currently standing, just to make it easier, at the fridge row. And I'm currently standing at the fridge column. That's where I'm actually located. I want to be moving towards the fryer, but every time I'm going to scan for an input direction of where the person wants to move using those WSASD keys. Okay, so I'm going to have a char that's going to be my direction. And then I'm going to use a while loop to kind of scan for what's going on and to keep scanning until I reach the fryer. So my condition is going to be until I get to the fryer, which means that my current row, whilst it's not equal to the fryer row, so that means I haven't found the fire, or my current column is not equal to my fryer column, and we can discuss the or the and in a second when we do the code. Okay, so I'm checking whether or not I have reached the fryer, but what I also want to do is I want to take some input. Yep, I want to scan things in. So I'm also going to use a scanf on the same line, and I'm going to read the input in until Control D. Okay, so how will I read in scan input until Control D? Yep, so I'm going to keep scanning a %C with a space, and I'm going to place it into my direction char, and I'm going to keep doing it until whilst it's all equal to 1, so whilst it's taking in 1 input successfully. Okay, now I've really stuffed the brackets. There we go. Okay, so I've got 2 things on my while loop that I'm checking for. Okay, this is what's keeping me going until Control D is pressed. Okay, and this is just checking that I haven't actually reached the final condition and gone past it. Okay. Okay, fantastic. Okay, so someone's saying, is equal to 1 the same as not equal to EOF? Okay, I'm going to do this again. Please don't use scanf until EOF. Okay, there is a way that you can get stuck in an infinite loop, which is why we just check for the correct number that should be returned. Okay, it is similar to that. There's no like contextual difference, but you can get stuck in an infinite loop if you scan till EOF in a few cases. So let's not do that. Okay, so we're going to keep scanning and keep moving. Okay, so let's move through this beautiful code. Okay, so we've scanned, and now I want to know where on earth we're going. Yep. So if that direction is equal to up, and I've got a hash define here. No, I don't. Let's make a hash define here to give us some directions. So up is going to be W, and then hash define down is going to be S, and let's hash define left as A, and let's hash define right as D. And after we have the movement, we're going to do multi-files. Exciting. Okay, so if my direction is up, then what I want to do, just so that you can see where we're going, you can see that I have in my entity over here face up, face down, face left, face right, okay? And I'm going to kind of move in those directions. And in my print map function, I actually check for those and I print out an arrow to show which way I'm moving, okay? So it helps to visualize it as well as kind of gives you an idea of what's going on. So I have kind of the ways that I can access it for printing. So now all I want to do is I want to set my entity to be that face up. So I'm going to say that at my map, at current row and my current column, and my entity is going to be equal to face up because I'm moving up, okay? And what does that mean if I've moved one up? What will change in my map? Where will I go? Will I change my row or my column? Row, yep. So that means I have to change where I'm currently standing. So my current row is going to be current row -1 because I've moved up, so I've gone up towards the corners of the array. Okay, excellent. Let's do an else if, and let's do another one. Direction is equal to the left. And then we're just going to try it with a few to see if it's working. And similarly here, I'm going to change my... So my entity is then going to be faced to the left. And what's going to change, my row or my column? It's going to be my column this time, yeah, because I'm going to the left. So my column is going to be -1. Okay, else if I'm going down, so else if my direction is equal to down. Okay, and then I'm going to face down. And that means my row is now going to be +1. And finally, if my direction is right, then I'm going to face right, and my column is going to change. Oh, phone calls. And I'm going to go up by 1. Okay, great. And then I'm going to move myself as well, okay? Now remember, I'm sitting inside the entity component, so I'm going to actually move myself to wherever I need to go as well. So map current row, current column dot entity is equal to the chef. Okay, and let's print our map again. Am I in a function? I'm in a function. Oh well, let's print out the map again. Okay, so let's see what that does for us. Okay, so we've moved along. A few people have fallen asleep. Okay, forgot to prototype. Okay. Okay, so what have I done? Oh, what have I done? I forgot to pass my map to this function as well. So we need struct location map and okay, and that means it should probably be my definition. Okay, let's run it. Sorry. Here we go. Okay, well now it's working and let's run it. The fridge is at 1, 2, 3, 4, 5, 6. Okay, and so now it's printing, so let's try walking. If I press... I should have really printed the map out each time, but clearly I'm not. So it's just given me one printout. It's only done one thing. Okay. What have I done wrong? Everything. That's what I've done wrong this whole lecture. Okay. All right. So what should I have been doing? I should have been printing my map a little bit earlier, I think. Every time I make a move, I want to print my map to see where it's going. How does that sound? Yeah? This is what I did wrong. My beautiful erroneous. Yeah. Nothing is, yeah. Okay. I promise your pain is going to be over so soon. And my pain also with yours. Okay, let's try moving. Okay, now we're moving. So, okay, so we're moving. We're not checking anything interesting. We're moving, and we're moving. Snaking. So now it's just printing it out each time. And when I get to the fryer, it will stop because that's one of my conditions. Okay, who's lost? Raise your hand. Yay! Quite a few people are lost. Great. Things are going really well. I feel like I should run over it quickly and then do multi-files quickly. I thought I had so much time today, and then I chose everything wrong. Okay, let's quickly run through it to see what's actually going on, okay? And then hopefully you're not going to be so lost to start with. Okay, I hope everyone was okay up to this point where we kind of placed everything initially on our map. And now you lost me at this find fire function. So when I do the find fire function, what's going on is that I am going to be moving around this map trying to find where on earth this fire is. So to this function, I give the map, I give where I'm standing, and I'm standing at fridge row column, and I'm also giving it where the fryer row column is, which is where the fire is. Okay, and then what I'm doing is I'm placing myself at the fridge row and fridge column when I say current row. So let's say the fridge is standing over here, and I'll label it out. Okay, so the fridge is over here, and so am I, and the fire is over here, and that's the fryer. Okay, great. So I'm trying to move from here down to here. I've got a chart direction where I'm going to scan some input in from the user. And my condition is that the current row can't equals to Fryer row, which means that where I'm standing cannot be this part of the array because that means I've found the fire. And my current column can't be the Fryer column. And then what I'm doing is I'm basically scanning in until Control D. So I'm going to keep taking in left, right, up, down. So whilst that %C is equal to 1, whilst the scanning in is successful and 1's being returned, I'm going to keep going into this loop. So if W was scanned in, I've got a hash defined that says W is up. So if my direction is up, so that is equal to W, what I'm going to do is I'm going to change map current row, current column. I'm going to say that I'm going to face up. So that means that this is now going to have an up arrow. And what I'm going to do then is I'm going to move myself along because if I've wanted to go up by 1, that means I want to actually move up by 1. So if I want to move up by 1, my row is the one that changes, not my column. That means I don't change my column, but my current row becomes current row minus 1. So I'm standing over here, 1 minus 0, 0. So I'm now going to over here. So I'm going to be at that column. Now, if I've done left, then it's scanned in the character D. And again, I'm going to change it to face left. And then I'm going to modify my column to be 1 previously. Okay? And so I'll keep taking input until one of these conditions has been reached. Either my scanning is Control D or I'm standing at the fryer, so I've been able to move successfully. And then what I do is I print out the map each time I make the move so that I can see where it is that I am. Does that make it better? Does that make it better, Aditha? Put you on the spot. You weren't prepared for it. Now you know how everyone else feels in this lecture theatre. Does that feel better? Hands up if that feels a bit better. Okay, thank you. All right, let's quickly do multi-files. Wow, okay. Sorry in advance. Let's do... Okay, so in your assignment, please do lots of functions. Use hash defines for magic numbers. Do good comments. And watch your line lengths. Be nice about that. Okay. What are multi-file projects? Now that you're completely fried, I'm going to give you something new to think about. But it's not that bad, I promise. And I've done the code for it, so you don't actually have to think all that hard. So big programs, when you get out into the real world, are often spread out over multiple files. I know you're really fried. I'm sorry. That was my fault. And there are a number of benefits to this, okay? And some of the benefits are that it improves the readability of the code. It reduces the length of the program potentially. You can also create some modularity, so you can spread your code out by subject. So you can have maybe things that are to do with, I don't know, mathematical functions, things that are to do with that. You can have different modules, and that means you can also have different people working on each module, which is what happens usually outside of university. There's a few people working on each project. And that means you can test things separately as well. So I can test the modules as they come in. I don't have to kind of have it all together. So we've been using the multi-file capability really. Every time we hash include a standard library, we are borrowing code from other files already. Okay, it's just that we're doing it from standard libraries. But magic, you can also hash include your own. Okay, so you can write your own little header files, your own definitions. And that will allow you to join different projects together as well. Allows multiple people to work, and it also produces code that you can then use in other projects as well, because they're modules that you can just plug in and out. Okay, so in a multi-file project, what you always have is you have a .h file, which is your header file, and that's the file that will have all your definitions, okay? You've already been using standard .h files, but not your own. And then you've got an implementation file for each .h file, and that's your .c file. That's where you actually implement things. So in the header file, you'll define what your functions are, your hash defines, and then in the .c file, you'll actually implement those functions. And then you have your main.c file, and that main.c file is the entry to the program, as we know, and we really try to have as little code in there as possible. We really just use it to call functions from and print stuff out sometimes, and that's about it. So when it is your own .h file, you include it by using double quotation marks, not less than and greater than symbols, okay? So the .h file, the header file, will contain all your function prototypes, so you can kind of give it to a developer and say these are the things that I want, and they've got the definition, so you now have to go off and implement this header file. It will also have your comments, which will describe how the functions will be used, so it gives you guidance on what to do in your implementation file. It will have your hash defines. It's basically a file that shows the programmer what they need to do, what they need to know to use the code. There is no running code in there. It's a definition file, basically. And then your .c file, that's where the implementation goes. And then your main.c, where you call things from. So as an example, and I've done this one for you, let's clear this and let's go into... Okay, so I've got this maths module because I just wanted to show you very quickly what it looks like. Okay, so inside there I've got first of all, my header file. Okay, so my header file, and this is going to be used in your assignment 2. Your assignment 2 is going to be given to you as a multi-file, which actually makes it a lot easier and neater for you to be able to see what's going on. It's actually much nicer. So in my header file, not long to go, I promise, I'm sorry. I will have any hash defines, and I'll have my function prototypes and any comments. So let's say I'm doing a little maths module. I'm going to have a hash define for pi just because I can. It's just for demonstration purposes. And let's say I've got two functions. One function that's going to have a square of a number, again, because it was just the simplest thing to do to demonstrate it, and a function that will calculate the sum of two numbers. So what I have in the header file is the prototype of it. Okay, so you'll have my return, the name of the function, and what I've given that function, which is enough to be able to write the function together with the comments up here. And then the second function is the sum of two numbers. Then I go to my implementation file. So you'll notice my maths.h, I'll usually name my implementation file the same thing as the .h file, because it helps to keep track of which header file belongs to which implementation file. Okay, so the .c file of the same name is the implementation file, and what it will do is it will actually include the implementation of those of the two functions that you've prototyped. So my square function will return number times number, because that's the square of a number, and my sum will return the addition of those two numbers together. So as you can see, I haven't printed anything out in here. All I've done is implemented the functions. And when I go to my main.c, that's where I drive the program from, okay? So as you notice here, I've got my maths.h. In my maths.c, what I include is that header file, okay? That's where my prototypes are sitting. And what you can imagine happens in very kind of basic terms is that it will get to this line and it will grab whatever's sitting inside maths.h and kind of place it on top of this file, compile it all together for itself, okay? So you've included the header, which is all the prototypes. Then in your main.c, you're going to include whatever libraries you're using. In this case, we're printing out, so we're doing stdio.h. And then we include any of the header files that we're going to use, so any of the functions that we're using. We don't include the C file, which is the implementation. We only include the H file that defines the functions that we want to use. Again, when it's your own header file, okay, you use double quotation marks. When it's a standard C library, you use the less than, greater than symbols. In my main, I give some variables. So I've got number 1, number 2, and then I just use a printf statement just to demonstrate what's going on. So I just print out my number, and I call the function in my printf statement, which will do something with that number, and the same with the sum. Okay, so let's see, how do you think I compile it? What do I compile? What do you reckon? What do you reckon I need to compile? Yeah. All of my files, including the header file? Not the header file. Okay. Good. I don't need to compile the header file because I've included the header file in my .c files. But what I do need to compile is all my .c files. So the way I would compile a multi-file project is I'll do main.c, maths.c, and then I'll just name the program. So what I've done is I've compiled any .c file, so my implementation of a main. And I might have multiple implementation files, right? I compile any .c files, and then I just move on with my life. So I'll do maths, and it will run, you know, I've hard-coded the numbers. It was really just to demonstrate how a multi-file project works. So it will just give you the square, and it will give you the sum of whatever the two numbers I hard-coded is, okay? Okay, so how does that feel? Hands up if multi-file projects feel great. You can't wait to use them. You're so excited to forget all about them for the next 2 weeks and then use them in week 7. Any questions about multi-files? No questions at all. How amazing. All right, I feel like I've fried your brains. I've cooked you to no return. But I'll see you on Wednesday for pointers, and that's really going to fry you more. So have a great week ahead. I'm sorry about the examples I chose today.